Right. So, what I want to look at today is, I guess it's kind of an attempt to try and tie together everything that you've done so far, which in summary essentially is you have um, developed a web API on a serverless platform, AWS in particular. We've used the cloud development kit to facilitate all of that. And then in the second half of the module, you've looked at developing front-end web app using, in particular, the React framework. So we've got a front end and we've got a back end developed, and we want to obviously tie them together or integrate them, uh, which means we need to look at how we might A, deploy a React web app onto the AWS platform, seeing as that's where our backend is, although they could be on different cloud platforms, but we'll stick with AWS. That's not that difficult. The slightly trickier part is how we get the front end to dynamically pick up the backend API. And by dynamically, I mean it actually discovers essentially the kind of the URL or the domain name of your API gateway. If you remember, we were using API gateway as a client-facing part of our serverless web API. And the reason we like to know how to do all of this is because it's part of the assignments two that you're working on. So in this lecture, we're going back to the whole CDK world. Um, so we need to get our mind back into that kind of gear all over again. Right. So the slides I'm going to go through, there aren't many slides that I need to go through, but there's a lot of demoing that I need to get through, and hopefully I'll get through it all within the 2 hour period. If not, I may need to go on it a little bit longer so that I can finish it off. And the only reason that's important, again, is because it will allow you to potentially use some of what I'm covering today in the assignment. Some or all of it, depending on how high a grade you're aiming for. So I'm going to go into this section here. There's no lab with this section, but there is a GitHub repo that I will give you access to, and that GitHub repo will be essential really for assignment two, and you're free to copy and paste any code from that repo or reuse any of the code in that repository for your assignment. That's assumed. There will be very little modification that you'll need to have to make to the code. You'll just need to tweak it a little bit and get it working, I guess, is the challenge for you. So anyway, there's a set of slides that I'll just use to help me to guide to guide this lecture. So just quickly by way of background, you would have covered this with Frank, although it probably was in the very first week of Frank's lectures, which he may not have uh, used it since then. But we just need to briefly talk about this idea of bundling a web app or creating a production version of your web app, your React app. Uh, and then we'll start then looking at the kind of the deployment of our React app to the AWS platform. So we want to look at the front-end app deployment to AWS, and we need to know, well, what services are available to us to facilitate that. There are two in particular, neither of which we've looked at, although you probably have looked at S3 already, which is one of them. The other one we will look at is called CloudFront, which you almost definitely have not looked at. Once we know then how to deploy a front end, then we look at the notion of a full stack web app where we've got a front end and back end all deployed to the AWS platform. How do we actually do that? And we're going to use CDK because that's been our main tool to facilitate provisioning infrastructure. Um, and the final thing we look at is because when you deploy your full stack app to the AWS platform, the domain name that you will be given by default is a CloudFront domain name, which is a meaningless domain name, really. It's fine, it'll work for us, but we'd like to give the user a more, to use that awful term, user-friendly domain name. So how do we actually create our own custom domain name and use that custom domain name for our web app? Okay, so the first point on that previous slide was bundling, this idea of bundling a web app, which is another way of saying creating a production version of your web app as opposed to a deployment version. Now, and what you've been doing all along with Frank is, when you're developing your React code, you typically run this command here, npm run dev, and just one second now, sorry. I get used to the keyboard sequences here again. npm run dev, and what that does is it starts up a development web server, which is essentially just a basic web server with some extra instrumentation built into it, which facilitates what's called hot module replacement, or HMR. HMR is this idea that you can go editing your React code, and when you save the file that you've been editing, that those changes will be pushed out to the web browser that you're currently using to view your React app. That's called hot module replacement, or HMR. And HMR is provided by this special web server that comes with the Vite tool that you've been using all along. Now, you would have also run this command here with Frank, although probably only once at the very beginning of his lectures with you. What npm run build does is it creates a static version of your React app. And it's that static version, that's what we deploy to the cloud. We don't deploy the raw source code that you would be using up here. We deploy the version of the code that is created from this command here. Now, all I'm doing here actually is in order to see whether the output of this command, which is just a folder with a few files in it, in order to see whether that runs or loads properly or not into the browser, you've got to install a local web server, just a standard web server, and there are lots of them out there. This is just one web server. There's a server called serve, which comes conveniently as an npm package. So if you install the serve package globally, you can then run the command serve from the command line, and you just point it at the folder that was created by this command here. And again, as I said a number of times already, you really actually done that already with Frank if you look back to probably the very first lecture. So this dist folder is a folder that was created by the npm run build command. And inside the dist folder, and I can show you, typically, switch to, yeah, here's a very simple React application. It actually only has one page. There's no routing in it, but that's okay. It's a React application that I got off the web that also uses the Vite tool. And when I ran npm run build on this application, and just to see, like, the source code has very little in it. There's only index main.tsx, app.tsx, and there's only one component, which is kind of a button. So it's pretty simple, right? But I ran npm run build on this project from the command line, and it created this dist folder up here. And this is the static version of my React app. And if we look at it, which you would have with Frank, if we look at the index.html, it's a skeleton page, but it does have references to two files which are inside in the assets folder. If we expand the assets folder has a CSS file and a JS file. The JS file contains all of your React apps TypeScript code after it has been compiled down to JavaScript. You know, if we actually look at that file, this is actually valid JavaScript. It's been compressed and minified, but it is the JavaScript, including all the node modules actually that would have been required by my code. All of that is bundled or packaged into one JavaScript file, which we call a bundle. And also any custom CSS that you have in your application, that will be bundled or packaged into a CSS file, which is this one here. And those two files are referenced from the index.html. And that's it. That's the complete production version of your React app. And that is what you deploy to the cloud, as we say. Okay, so that's the dist folder. That's all by way of background. Background meaning you already know this, I hope, or remember it anyway. So the next thing, so if I want to deploy a React app to AWS, what options are available to me? The simplest option is to use the S3 service. You can actually create an S3 bucket and you can configure that bucket so that it hosts a website, and I'm specifically I'm purposefully using website here. Okay, and you put all of your HTML files and any JavaScript files and CSS files into this bucket. And because you've configured the bucket as a host for a website, then the AWS S3 service will generate a URL or domain name for your website, and then you can use that to load the website into your browser. Now, our static React app is essentially a website. And so if I want to create my bucket and configure it and also upload my dist folder to the bucket, if I want to do all that in an automated way, then I can use the CDK framework to do it. And what I'm showing you on the right there is the CDK code to achieve that. Yeah. So first of all, I'm creating an S3 bucket here. I don't think we actually created any S3 buckets when I was lecturing you, but you know, you kind of remember all this kind of stuff. It'll come back to you gradually, hopefully. So there is a what do we call them, an L2 construct that allows me to create a bucket and configuring the bucket with some standard kind of stuff. Now it's this configuration setting here. This is the one that tells the S3 service to use this bucket, not just as an ordinary bucket, but use it as the host for a website. That, however, just creates the bucket, an empty bucket, and it does configure it according to these settings here. This piece of code here is how, in the CDK world, how I essentially upload my website to the bucket. So there's an S3 deploy L2 construct that allows me to do it. And all I'm doing is I'm telling it where to find the stuff that I want to upload to the bucket. So I'm pointing it at the dist folder. and and I'm telling it here where I want it to upload it to my bucket. Okay, so this piece of code here carries out the uploading to the bucket, and that's it. Okay, all I'm doing here then is I'm outputting to the terminal the URL that was generated by the S3 service for my website. Okay, which is, as you can see, it's an S3. Well, that's just the name of the .s3 here tells me that it's an S3 uh, domain name, generated domain name. This part here just comes from the actual CDK project name, I think, and the rest is just auto-generated. So just to prove that earlier on, I now go into, do I have that project? Let's see. Yeah, here's my CDK project with my CDK file, which I've been talking to you about. And I did a CDK deploy. There are no lambdas or any of that in this project, obviously enough. Here's my dist folder. So I did have to manually copy the dist folder from my React app to my CDK project. We don't like that kind of manual operations, but we'll just live with that for this module anyway. So there's my dist folder. And I ran the deployment earlier on, and it gave me this generated domain name from my website stroke web app. And so if I click on that, I didn't show you what the web app looks like, but it's not too impressive. Okay, that's it. Okay, it's just it's a single page. There aren't multiple pages. There are no navigation links or any of that. That doesn't really make any difference. All it has is this counter that I can just click on. Yeah, and we can see. So that worked fine. So we can just use S3 to uh, to deploy our React app too. Now the problem though with that is that if our React app uh, experiences very high volumes of traffic, very high user access, then all of that user access is targeting my S3 bucket. And so if my web application has global attraction, then that single point of contact is problematic because S3 may not be able to deal with the volume of user interaction, especially if there was lots of gets and posts and deletes and lots of interaction anyway with my React app. Uh, how can we deal with essentially kind of the scalability side of our React app? And the answer from AWS's perspective is to use a second service called CloudFront. CloudFront simply is a CDN, content delivery network. I'm hoping everybody knows what a content delivery network is, but I've given you a definition of it there in the first bullet point. It's essentially a globally distributed network of computers distributed that they essentially all they do is they cache content. Now, in our case, the content that they would be caching would be our the pages of our website, which in our case, okay, is just one index.html, but it would also cache the JavaScript and CSS bundle files, caches them locally. And that means then that when a user tries to access our React app, then hopefully it will get what it's looking for from one of the servers in the CDN, and it'll be a server that's geographically close to them. And so it's going to get a quicker response time. Uh, uh, the latency will be lower, and there won't be as much traffic hitting the S3 bucket because the this network, the CDN network, will have cached locally copies of the files that the users are looking for. Now, this network of servers, the servers are sometimes referred to as edge location servers. Edge as in they're closer to the edge of the network, closer to the user. They're also called POPs, points of presence. Yeah, so these terms are used interchangeably. And the content in our case, okay, the content in our case is web assets, but we could use CDNs for any type of caching. So we could have documents, PDF documents, Word documents, Excel spreadsheets, any kind of content that we want to make available to our user, to our geographically distributed user base. Yeah. Uh, could be videos, etc., etc. So content really can be anything. When I looked, now these figures are actually from last year. They may have increased a little bit, but the CloudFront CDN has over 400 edge location servers, and they're distributed as I'm mentioning here. So kind of visually what I'm getting at here now is, so okay, we may have our S3 bucket with our content, but you may have a user, the kind of dots that are on this image, Maria, represent individual edge location servers or POPs. And so when a user tries to access any of the content in the S3 bucket, that request from their browser will first of all be directed to the edge location server that is geographically closest to them. And it will check to see, does it have a cached copy of the content already? Because maybe another user in this geographical region would have requested the same content prior to this user here. If it does, then it'll serve the content directly to them. If it doesn't, it does have to go back to the S3 bucket for the content. The S3 service will respond with the content. The edge location server will cache it locally and then serve it to the user. And there are obviously time to live settings on the content of the cache. Now, from CloudFront's perspective, there are two AWS resources that are used, that it uses, or the kind of terminology that CloudFront uses. It talks about origins and distributions. And we'll see now in the CDK code, we'll see ourselves creating an origin resource and creating a distribution resource. The origin resource, that represents the source of your content, which in our case is S3, but there are other potential origins for a CloudFront distribution. The second, so that's a very tangible thing, the origin. I'll call them constructs really to use the CDK term. These are two L2 CDK constructs, an origin and a distribution. So the origin construct is easy enough to understand because it kind of relates to something that's we can imagine physically. A distribution construct is slightly more abstract, but it essentially represents your particular CDN distributed across the network of edge location servers. And the distribution instance that you create, it's kind of responsible for, as I'm saying here, for managing the content of the edge location servers. Takes care of when the edge location servers should remove entries from its cache because their TTL has expired, and some other aspects as well, which we'll mention later on. So we need to create these two instances of these two constructs in our CDK in order to essentially create a content delivery network for our React app. We're still focused on the front end now of our full stack app. We're not talking about the back end at all. This is just another kind of visualization. So we have our client, our browser, or it could be a mobile app, I guess. It's going to send the request the URL of the request will be a domain name that has been generated for your distribution. When you create a distribution, CloudFront assigns a domain name or URL to it. And so that's what all of our users will use. But when they submit a request for that particular domain name from their browser, their request uh, will hit the edge location server, or that request will be directed to the edge location server that's geographically closest to them. That's where it'll be dealt with first. It's going to check in its cache. Does it have that content? If it does, it serves it. If it doesn't, it goes back, it sends a request, or it kind of forwards the request back to the origin, which in our case is going to be an S3 bucket, but there are other possibilities, which I think I mentioned in the next slide, just for completeness. The origin is going to respond to the edge location server, it caches it, and then serves it to the user. A little bit more detail on origins. I guess the dominant origin would be S3 buckets, admittedly. And so from a security point of view, we'd like our S3 bucket to be secured such that it can only be accessed by our CloudFront distribution. In other words, users cannot access the S3 bucket directly. Yeah, I think that's a reasonable objective to have. And so to do that, you have to create what's called an origin access identity. It's kind of an odd name, although it's also referred to as an origin access control. This is kind of the newer name for it. This was the older name, although identity is kind of useful in the name. You could think of an origin access identity as a sort of virtual IAM role that you define, and you attach whatever privileges you want to that role, and then you assign that origin access identity to the distribution or to whoever or whatever you want to give access to the bucket. Now, we only want our CloudFront distribution to have access to the bucket. So we would assign an origin access identity, aka an origin access control. We would assign that to our CloudFront distribution. And in that way, then we are ensuring that only our CloudFront distribution has access to our S3 bucket. There's no other way of bypassing CloudFront to get direct access to the bucket. You can use S3, you can use an origin, sorry. You can use it as an ingress. Well, sorry, you can use an S3 bucket as an ingress. An ingress is where we actually allow the user to upload content to our origin. And that may be a requirement, let's say, in a React app, where you want to allow the user to upload images or whatever. So you can actually build that into a CloudFront distribution as well, although we won't be looking at it. Alternatively, these are some other alternatives for an origin. So an actual API gateway could be an origin. And that's not hard to visualize. If I go back to the previous slide, if you imagine I've got an API gateway here, which as we know now is a front for an API. So you would have Lambdas over here and DynamoDB and all that good stuff. And so our GET requests will still be directed, and we plug in our API into our CloudFront distribution. So GET requests now could be, okay, coming from Postman or coming from some other application, doesn't really matter. Our GET requests are going to be dealt with in the exact same way, except in this case, if the content isn't cached locally, then the edge location server is going to send the request to our API gateway. It's going to just pass it on to the backend. Eventually, the response is going to come back from the backend, cache locally, and eventually arrives back at the original source. Yeah, so it's not hard to visualize how API gateway could be used as the origin for a content delivery network. Similarly, an application load balancer could be an origin. Even an EC2 instance, you can imagine an EC2 instance that's actually hosting a website. You might have a web server running inside an EC2 instance. Would probably be old school, but still. And you want to stick a CDN in front of your EC2 instance, then you can connect them up. Or this might seem odd though, if you actually are using S3 as a website, you could use that as well as the origin. I am making a distinction here between using S3 here and using S3 here. When I talk about S3 up here, I'm talking about S3 simply as an ordinary bucket that contains content. Whereas here I'm talking about an S3 bucket that has been configured as a website host. It's a kind of a subtle and almost insignificant difference, but in the documentation anyway, it the documentation makes a slight distinction between the two ways that we use S3. And in fact, we're going to be using S3 in this format here, not as a a host for a website. I don't think there's anything new actually. Well, sorry, the only thing that I've kind of added in now to the picture here is this origin access control or origin access identity. Okay, that is what gives these edge location servers, it gives them access to the origin, which I'm sticking with as being an S3 bucket. Okay, demo time. We want to provision a CloudFront, sorry, yeah, we want to provision a CloudFront distribution for a standalone React app using S3 as the origin. Right, so if I switch over to this project, now this project has an awful lot more in it than what I'm trying to achieve here in this statement. And I'm just going to pick out the parts of the CDK project in VS Code that we're interested in right now. And we'll kind of just conveniently ignore other parts until later on in the lecture. So, even though there are two, this is a multi-stack app, we are not interested in this stack for now. We're only interested in this stack here. And despite it says it's called full stack app, we're actually only concerned with the front end. And if we look, well, sorry, before I do that, you can see here as well, I've created some custom constructs. And the only one we're interested in right now is this one here. You'll actually recognize these from before, Auth API and App API. So when eventually I get to talk about a full stack app later on in this lecture, these two constructs will be relevant, but right now they're not relevant. The only construct we're interested in is this one. And the only stack we're interested in is this one. So if I look at that stack, and we are going to overlook everything. We're going to overlook all of this stuff here. We're actually creating a user pool, but that's all backend stuff, so we're not interested in that now. We're creating a client for our user pool, not interested in that. We're creating an instance of our Auth API, we're not interested in that. We're creating an instance of our App API, we're not interested in that. The only thing we're interested in is this bit here. Creating an instance of front end, and front end is just a custom L2 construct that we're creating for ourselves. We're passing some stuff to it, and we're not interested in any of that either right now, which means the only thing we're interested in is here's the implementation of our custom L2 construct called front end. And at last, we start to see stuff that we are interested in. First of all, we've got an S3 bucket here. Now, I've purposefully commented out this line here and this one, as it turns out. Those two lines, in particular this one here, no, sorry, this one here, that is what makes an S3 bucket. Uh, that's what if makes it an S3 bucket that's hosting a website. When we enable that, if I go back to the slides and I go back to this one here, when you set that in an S3 bucket, set that configuration in an S3 bucket, that's what tells the S3 service you should use this bucket as the host for a website. But I am not doing it in this case because I do not want S3 to configure this bucket as a host for a website. I just want it to be a bucket that contains content. So I left it there to try and reinforce that point. It's in some extent it's a small point, but it's an important point. Everything else is predictable enough that I want the bucket to be destroyed when the stack is destroyed and all of that kind of stuff. And it's read. Sorry, its read access, is blocked off, which is kind of going back to the point that I want my bucket to be very secure. I don't want any access holes opened in it. This is where I'm creating my CloudFront distribution, which is that second L2 construct. And a number of this configuration settings of this L2 construct are not relevant to us right now, as in we're not interested in that. This we are interested in. We're telling it because when I deploy this stack, what the CloudFront service will do is it will generate a domain name for this distribution. And so if any client sends a request to that domain name and they don't specify a path within the domain, then I'm telling it here by default, serve it the file called index.html back to the client, which in our case will be the index.html of our static React app. What else? We were not interested in that. This is just what are we saying here is that we want essentially to use only HTTPS or TLS. Oh yeah, here is where we're actually creating an object access control, or the old name was an origin access identity. And you can see that I'm giving the origin access control, I'm enabling read access to what? To my bucket, to source. Source is my bucket. Yeah. So that's kind of buried within the distribution as opposed to a separate entity. I could probably have created this as a separate entity. Created this as a separate entity, but I've embedded it in the distribution. But either way, that's really important from a security point of view. And we can skip over all of that stuff, and we can skip over all of that and that. And here is where I'm just uploading the dist folder to my bucket. I'm uploading something else as well, but that's not relevant now. So in summary, all I did was create an S3 bucket, and it's an ordinary bucket. It's not a bucket that's configured as a website. created a distribution with most of it, the kind of default settings, created an origin access control and gave it read access to my bucket and attached that origin access control to my distribution. And then finally uploaded my content to my bucket. And when I do a CDK deploy of this stack, what I get back is, as a result of one of these outputs here, I get back that as the domain name that has been generated, and you can see that it's got a .cloudfront.net. It's in the cloudfront.net domain. So this domain name, uh, when I input that into a browser, I use my images to help me. When I CDK deploy that stack that I've been showing you, it's going to, which is the best one? Let's use this one. It's going to push out to all of the edge location servers, maybe not all of them, but many of them anyway. We won't get into it. It'll push out to them the details of this new CDN network that has been uh, created by CloudFront. And it will obviously create my S3 bucket. It'll attach the origin access control to that bucket. It'll associate that control to my CDN network, my CloudFront distribution. They're interchangeable, those two terms. And then, everything works as I explained already. I guess so. All I need to do is, if I grab that domain name and input it to a browser, copy that. Um, I'll open up a new browser tab. Close that one off actually. And what I'll also do is open up the developer tools and go to the networks tab. Okay, and I'll enter my URL here. And it looks like I got the response back. Okay, and over here, what we can see are, we can see uh, the JavaScript file associated with my React app, the CSS. These are the two kind of bundle files that I talked about. These two here correspond to these two here. And if I if I select any one of them, let's take this one here. And if we look at the response headers associated with the retrieving of this file, what we can see is, if you see here, right, Xcache, that's the only way I can kind of prove to you that the request from my browser went to a CloudFront edge location server. That edge location server looked in its cache for the content that I've requested. It wasn't there, so it actually went back to the S3 bucket to get the content, and that's why I'm getting a hit uh, from CloudFront. The reason it's a hit and not a miss is because I actually did this just before the lecture. So If it had been the very first request, then it would be a miss. And, on this, if I go back to the slides, I'm showing you that here actually. Let's see. Here's an example of a miss from CloudFront. So the slides are slightly in the wrong order. I guess I should have shown you this one first. And then, later on when I refreshed the browser a couple of times, I eventually got a hit from CloudFront. A hit from CloudFront simply means that it found the content that I was requesting from my browser. It found it in the edge location server that's geographically closest to wherever I was when I requested this content. Okay, I'll just pause in case there are any questions if you're staying with me in terms of what I'm trying to demonstrate here. What's next? Now, when I did the CDK deploy of this app, and I've already mentioned that there's a lot more going on in this app than just the deployment of my React app to an S3 bucket and the creation of a CloudFront distribution. It's also deploying a backend, and that's why I'm getting extra output here. I'm getting a URL of an auth API and an app API, but we're not using them right now anyway. Okay, there are no questions, so I'm going to keep going. Um, Now you've been using caching with Frank, so you understand the notion of caching. So really, I don't need to talk over this slide, I don't think. What you can do actually, maybe I should just quickly do that. If I go back to, if I go to AWS, maybe I should really show you that. Now, if we look at the CloudFront service, here's what we're looking at are the various distributions that I have deployed, and there's only one, surprise, surprise. So this is the CloudFront distribution that was created as a result of the code in my CDK project. Also, maybe we should just quickly look at the S3 service. Come back to there maybe in a second. In terms of the S3 service, now I actually have two apps, two React apps deployed at this stage. One was the React app deployed to an S3 bucket where the S3 bucket was configured to be the host for a website. The other is an ordinary S3 bucket. Okay, and that ordinary S3 bucket is linked to my CloudFront distribution. And just based on the dates, I think we look at April 28, these two here kind of correspond to those two buckets. And if we look at, just look at one of them, the content looks familiar. There's our index.html. There's the assets folder. Here, the two uh, uh, bundles related to my React app, the JavaScript one, the CSS one, and there's an SVG file as well. Okay, so no surprises there, really, I think. I'm going back to CloudFront. You can actually trigger a manual kind of flushing of the caches in the edge location servers. That's referred to as an invalidation. Normally, entries in the cache are expire. They're assigned a time to live, and you can configure that time to live in your CloudFront distribution configuration. We left it at whatever the default TTL is. But if I want to force my edge location servers to flush their caches, let's see, can I do that? Um, Maybe this will do it. You can be specific about certain parts of the cache that you want to have flushed. I'm taking it here, telling it to flush everything. So if I trigger that, so what CloudFront is doing now is it's sending out a request to its various edge location servers to uh, purge the cache related to my particular distribution, which obviously is something that takes a little bit of time. I'll just give it a few moments to kind of complete that. What I can say in the meantime is every time you do a CDK deploy, we know, if you remember from the whole CDK world, when we make changes to our CDK stack, we need to do a CDK deploy to update the deployment. Now, if your deployment includes a CloudFront distribution, then it will automatically trigger a cache invalidation for that distribution, which makes sense because the edge location servers, they don't really know what part of your CDK stack have you changed. So the safe option is that the CloudFront service will tell the edge location servers by default to purge their caches. So hopefully that has run through now, which means if I go back to here and if I do a refresh, if I'm lucky, then I'll get a cache miss down here because let's see what happens. If I don't, I don't, and I'll just keep going. Let's do a refresh. And let's again select, doesn't really matter which one I select. Let's select this one. And voila, I get a cache miss. So I'd have to go back to S3 in this case to get my index.html and in particular the JavaScript file. And if I refresh it, I think you need to refresh it kind of twice before it actually decides to cache it. So if I do a refresh and another refresh, now I should be getting a cache hit. Yeah, I'm getting a cache hit. So I kind of proved that caching kind of works okay. Although, that just works. You don't really have to go tweaking it at all. It's only the rare cases where you want to do a manual flushing. Okay, back to here. So I've the cache keys. Yeah, just a little bit about the internals of the cache. We know that essentially all a cache is a key value store. And so the question is, what are the keys in a CloudFront distribution edge location server cache? Well, the keys are actually determined from the request that the browser is making. And the key comprised of, by default, the key is comprised of, it's kind of a concatenation of the host name, which in our case, was uh, this part here, the part that was kind of generated by CloudFront, the host name plus the resource, the resource name, The resource name in our case would be index.html. It would also be the names of these two files, the JS file and the CSS file. They're the resources in our case. So it's a concatenation of those make up the cache key name. And that's what I'm demonstrating here. But you can actually be more specific. And if you want to be more specific, that means you've got to describe the structure of the cache keys in your CloudFront distribution CDK code. So you can add on things like HTTP header in your as part of your cache key, or cookies can be part of the cache key, or the query string if there was a query string in the original request. They can be all added on to this default cache key. You've got a lot of control really over the structure of the keys in your edge location server's cache. And all of this is what is called the caching policy associated with your CloudFront distribution. So, as I say, it's essentially it's just stuff that you add into this configuration here. So we've left all the defaults apply in our case for convenience. I'm just giving a bit more detail here on it. Now, to be honest, right, you don't need to worry about any of this, right? So you can, in terms of if you want to add on HTTP headers as part of the cache key, the kind of options you can have are none. You don't want any HTTP headers to be included, or you can specify a whitelist of HTTP headers that you want to have included. For cookies, you can say, I don't want any, or again, you can specify a whitelist, and similarly for query string. So lots of control available to you. You can also control the TTL of your cache entries. That's referred to as the kind of caching policy associated with your distribution. There's also something called the origin request policy. Now, again, I'm telling you about this, but uh, I suppose the short-term interest that you have is, do I need this for all the assignment? And the answer is no, you don't. But I'm just covering it anyway for completeness. The origin request policy, what that is related to, if I go on to the next slide. So here we have a client sending a request to a CloudFront edge location server. And here's our origin back here. Doesn't matter what the origin is. This particular image that I got, I think, is using an EC2 instance as the origin, but that doesn't matter. Let's imagine that this is the S3 bucket here. Now, what the origin, what did I call it? The origin request policy. What that relates to is, so this might be the request from the client to the edge location server, and it has some query strings in the request. It has some headers, HTTP headers. It has some cookies, right? So what the origin request policy relates to is how much of this uh, detail in the request, how much of it has to be forwarded on to the origin if we do need to contact the origin. And that's what you indicate in your origin request policy associated with your CloudFront distribution. So for example, like we're saying down here, I'm specifying a caching policy and I'm specifying an origin request policy. The caching policy, if you read the detail, it says, look, I want the host name and the resource name to be part of the cache key. That's kind of default anyway. But I also want to include the authentication header as part of the cache key. And you can see there was an authentication header. So it's the value associated with that HTTP header that's going to be part of the key in this particular cache. In the origin request policy, I'm telling it, look, these are the things that you need to include in the request from the edge location server to the backend origin. You only need to include these. Anything else you can leave out from the source kind of request if you like. Okay, interesting, but not relevant to the assignment. Caching validations. Have I lost you? Are you still there? I think you still are.
Still here. Yeah.
Yeah, okay, yeah, that's fine. Caching validation, I've already spoken about that. Uh, just quickly, the caching validation happens automatically every time you redeploy your stack, but you can do a manual caching validation, and I showed you how to do that on the AWS platform. Finally, well, not finally, sorry. We come to, let's say we want to deploy a full stack now in this case, where a full stack is comprised of in our case, a React front end, and let's say we have two parts to our back end. You might remember when I was lecturing you a number of weeks ago, we got to a stage where we could deploy a Cognito-based auth API, and we had a kind of skeleton app API. And you developed, you actually included all of that in your assignment one for me. So let's supposing as our backend, that's what it comprised of, so that we're familiar with all of that. What's new now, though, is that we want to include a front-end deployment in our CDK stack, and also we need to look at how do we get the front end to pick up the URLs of our two backend APIs. Do we have to hard code them in the front end React code? Hopefully not. It's a solution, but it's not a great solution. Can we automate it in any way? And there's it's just a pattern really. It's not something that the CDK helps you with. Really, it doesn't actually provide any solution. We've got to come up with our own solution. But I did come across a nice solution on the web, and kind of makes sense as to how it works, and I'll show you how it works. So this is our objective anyway. And that kind of brings us back to the CDK stack, a lot of which I skipped over, but now we need to drill into it a little bit. So, where do we start? Let's see. We're still going to ignore this stack for a while. This is the only stack that we're interested in. So again, let's revisit this stack. And now we're creating a user pool because we're going to have an auth API as part of our backend. We know about that from before. We're creating we will eventually want to, let's see now, sorry. Trying to remind myself of what's going on here. Here's a pool ID. Why am I doing that? Oh yeah, it's okay. Okay, we're creating our user pool. We're creating a client for our user pool. And we're creating an instance of our auth API, which is conveniently kind of packaged inside in this construct here. This one here. And look, you've seen all of this code before with me. Admittedly, it's six weeks ago, but if you go back and look at it, it'll all make sense to you. I'm not going to talk over that. So that creates a number of lambdas, an API gateway fronting those lambdas, and all the lambdas are dealing with user sign up, sign in, all that stuff. Okay, back to here. So we're creating an instance of our auth API, passing in the user pool related information into it. We're creating an instance of our app API. And our app API, which I'll just briefly look at, it just consists of, let's It's this one here. It's just a REST API with one endpoint, and the endpoint is pointing at one lambda, which is, where's my lambda? This lambda here. And all the lambda does is it returns it expects a HTTP GET request, and it just returns a simple message, which is this message here. Yeah, all of these lambdas here are the lambdas that you would have seen already related to handling sign up, sign in, and all of that stuff. So we don't need to look at those. Okay, back to my stack file. And uh, so, and finally, then we create our front end part of our deployment. And we've looked at some of that. But let's go back now and notice here I'm passing in to my front end construct, I'm passing in the URL of my auth API and my app API, my auth URL and my app URL. I'm passing those into it. That's important. And we needn't worry about this certificate for now, and we needn't worry about the zone for now. So let's go back to our front end custom construct, which is here. And let's start from the top again and go down. We have our S3 bucket as before, nothing new there. We have our distribution as before, nothing new there. Now here, no, sorry, we're not interested in that for now. Here, I'm just creating a local TypeScript stroke JavaScript object, which contains within it just two properties. Those properties are the values are the URLs of my auth API and my app API. But it's just a JavaScript object. That's all I'm creating there. Interestingly, though, in my deployment to my bucket, I am actually uploading to the bucket this JavaScript object, which of course you can do. You can upload JavaScript objects to an S3 bucket, as well as uploading files of any type. So my S3 bucket now is going to contain essentially this JavaScript object, which has within it the URLs of my two REST APIs, my auth API and my app API. And the rest is, did I talk about this stuff before? Oh yeah, that's the rest is as before. And if I switch over to my S3 buckets, let's see, let's go into S3. And the bucket that I'm interested in is, let's see, it's this one here. Don't worry about the bucket name, but the content is, the index.html of my React app, the various asset files, and here's the config.json. Sorry, just go back to here. Oh yeah, so what I'm saying here is upload the config object, this one here, and give it the name config.json within the S3 bucket. And that's why we've got an object within our bucket called config.json. And if we look inside it, Can we look inside it? I open it up. It's got a set of key value pairs. This looks like it's the URL associated with the auth, uh, the app, sorry, the app API. And over here we've got the auth URL, and that's the URL that was generated. And those two URLs, they kind of tally with, I'm jumping around a lot now. They tally with these two URLs here. Yeah. So they're the URLs of my two backends. Now, the next thing though is how does my React app get access uh, to this JSON object? Let's go back to it. How does my React app get access to this JSON object because of it? Sorry, this JSON object here, uh, or file, because if it can get access to it dynamically, then that's how it can actually discover the URLs of your backends and communicate with them. We don't have to hard code them into the React code. Now that's a React issue really, and so I'll just briefly show you the React code that does it, but there's nothing new in the React code. So if I look at the React app itself, we haven't looked at any of the detail of the code so far. But if I look at drill down into it a little bit now, um, I've got, let's see, I guess if we start here in app.tsx, should I start there? I'm importing here two functions from a file inside an API slash backend. So if I just leave that open, here's API, the API folder in my React code. And here's backend file. That has an import at the very top. There's something getting in my way here now. That has an import at the very top, and it's importing from a file called .config, which is down here. So the effect of this import statement here is to cause any code in this to execute. And so at the very beginning, I'm actually making a fetch call for a file called config.json. And config.json is in the same folder as wherever this file was contained. And of course, that folder is the base folder of my S3 bucket. So when this executes, and it's going to execute really as part of the kind of boot up of your React app within your browser when it's loaded into your browser, it's going to grab the config.json, and I'm just creating a local JavaScript object here within my React code, which contains the URLs of my two backends. This is just a static JSON object that I'm creating within my React code that is now running inside my browser. Okay, this has fetched the JSON file from the bucket, and I'm using the contents of that JSON file, and we know what it looks like. I'm using it to set up this local object that's going to be local within the browser itself. And so if I go back to backend, I suppose. So this now is going to be a reference to that object within my React app that's running inside the browser. And you can see that I'm using it within these two functions here. If I take this function, what this function is going to do whenever it's invoked, and it will be invoked from one of my pages, this function, you can see it's making a fetch call to one of the APIs, one of the URLs that's inside in this object. This object again is this object here. So it's essentially what I'm doing here in backend. I know I'm jumping around, so you obviously have to look at this code later on yourselves. What I'm doing here is I'm making a fetch call or HTTP GET request to my app API, which will eventually finish up triggering the Lambda associated with the app API. In this one here, I'm making a request from my React app to the auth API, and it's actually a post request. This is essentially a login request. I'm sending a post request to the sign in part of my auth API. And I've hard coded a username and password, which obviously isn't great, but I'm hard coding this username and password. Normally, I guess you would get that off some sort of simple login form in your React code and pass it down into this function. So what I've showed you is the React code that dynamically discovers the URLs of your auth API and your app API. And the final piece of the jigsaw is if I go into app.tsx, I have two use effect invocations in there. This use effect is going to trigger the invocation of the function that talks to the app API. This use effect is going to trigger the function that communicates with the auth API backend. That this authentication function and the get demo endpoint function, these two functions are the functions that are inside in my backend file. And does it work? Well, the only way I can prove that it works is in the actual page that's being displayed in the browser. Sorry, let's go back up to here. I'm just using a state variable to hold the message that will be returned by my app API. And the message should be, jumping around a lot now, I know, but the message from the app backend Lambda is this Lambda here, demo. The message it returns is success in contacting the API. And surprise, surprise, if I actually go to the browser, see this message here? Okay, that's coming from the Lambda. And I'm simply displaying it in my web page. I go back to my React project. You can see here, I've just stitched in, let's see, I've stitched in this bit here, where I'm just displaying the contents of message. The default content of message is no response from backend, but we don't actually see that. Although, if we were on a very slow network, you know how the use effect works in React. This will be the initial value of message, but after the use effect has completed execution, the message is going to change as a result of invoking this function here. And I do a set message. I change the contents of the message, and I change it to the message that was included in the response from my app API. I'm also console logging the full response just to show you what that looks like. And if I go back to here and open up if I go to the console here, and if I expand this guy, this is, well, there's not a whole lot in it, but this is the full response from the app API. I'm also in the second use effect, I am console logging the full response that I got back. That would be the response from the sign in of user A, that request that was sent to the auth API. And this console log, if I look at it in the browser, lo and behold, it includes a JWT token, which you remember was part of that Cognito stuff that we looked at a good while ago. So this is the token. So you would store this token now locally within your React app and use that token if you wanted to secure certain parts of your React app. I'm sure you have questions in your mind about what's going on here. I will give you an opportunity to ask questions now if you have them. I appreciate, though, it may need spending some time browsing around. I will give you access to the GitHub repo that contains all of this code, which obviously you need to spend some time poking around. But do you have any questions right now that come to mind?
Just one, it might be just a little bit of housekeeping stuff, Diarmaid. So what we put together for assignment one as a structure, do you feel that still should hold and it's more about layering in stuff, or do you think we actually need to make actually some changes? I'm talking more so about, I suppose, the lib folder where I don't have it broken down specifically by components and then to put in stacks. Does that need a bit of tweaking for the
I'd say it does, yeah. I'd say you should
okay.
take your submission from assignment one,
Yeah.
and you should add on, well, for assignment one, if we look at the lib folder, um, sorry, that's not assignment one. This is closer to assignment one. In your lib folder, uh, if you did the Cognito stuff, you should have
I
an
did.
app API construct and an auth API construct.
I do. It's
Yeah.
just that I don't have it in a constructs folder.
Well, okay,
This doesn't matter.
no, that doesn't matter. It's
Okay.
just a simple organization.
Okay.
You need to add in a front end construct, and you can literally lift uh, all of my code and make whatever changes. Not a whole lot, I'd say, though. Um, you will have a stack file. You can literally, I think, use my stack file and make whatever minor changes may need to be made to it. Very little, I think. Of course, in the Lambdas folder, then if we go jump over there, in the Lambdas folder, you're going to have uh, all of the auth lambdas as you would have had in assignment one,
Yep.
and you're going to be adding in your own lambdas here.
Yep.
Um,
But that doesn't change with the integration, right? We're not adding any new lambdas.
no,
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 right.
you're not, no.
Okay.
You may need to, well, yeah, I don't think you're going to need to make any changes to them. On your React side, then, which means I switch over to here. You can reuse a lot of the code that I'm giving you, like the API backend functions. You may have other functions in your backend, like you may have functions that are talking to TMDB directly, for example. Um, uh, but in this case now, your React app will be talking to TMDB directly, and potentially it will be talking to your assignment one APIs, both the auth API and the app API.
Right.
And if you do want it to be communicating with those, then you're going to need this code here.
Okay.
Yeah. And you're going to need the config.json, the config.tsx, sorry, this one here. You're going to need that. Direct copy and paste. And finally, uh, now I've just
So
in
sorry, Dermot, that config.ts, and you said it earlier, I think you said we also need to copy in the dist folder.
well, the dist folder is created when you run npm run build.
Okay.
So this is
Okay.
your, let's say this is your assignment to React project that we're
Ah, I
looking at
see.
here,
I
right?
see.
You
Yep.
run npm run build, that creates the dist folder. You're going to copy that dist folder over to your CDK project.
Oh,
Okay.
okay.
So
Yep.
you're going to have two separate folders, really. You're going to have two separate, let's call them projects, maybe. You're going to have your React project and you're going to have your CDK project. Now, it would be nice if we could package them all together into one project, but that just requires, a little bit more kind of thought in terms of how we might structure that. I think it's fine if you leave them as two separate projects.
Okay.
Um, what did you ask me there now, just again? Did you?
No, I think you're on the right track. Yeah, it's just more about kind of how to what changes from
Oh,
assignment one to
sorry,
make, but
sorry.
I think you're already answering it, to be
Yeah.
honest,
No,
Dermot,
you
so
asked
that's
me
great.
about the dist folder. So in
Yeah.
your React project, you every now and again you're going to run npm run build. That creates your dist. You copy that over into your CDK project. And you're going to have to remember every time I make changes to my React code, I'm going to have to run npm run build and copy it over. So you're going to have to remember to do that. And somewhere in here, sorry, not that one, this one. There's my dist folder, so I had to do that manually, which, as I said, is not great, but so be it. Um, any other questions? No.
And the npm build then will include deploying to S3 bucket, right? The React app.
No, npm run build is totally on the React side. It just creates a static version of your React app. Yeah.
Okay.
Okay, that creates the dist folder. You copy the dist folder in over to your CDK project, which is kind of what we're looking at now. And then you go CDK deploy. Every time you copy over the dist folder, that means you've got a new part uh, to your deployment, even though you may not have changed any of the code in your CDK project, because you've changed the dist folder, you're going to have to run CDK deploy again. Now, the CDK deploy is going to simply update the contents of your S3 bucket, because the contents of your S3 bucket includes the contents of the dist folder, as well as that uh, config.json file. But the config.json is not the only time that's going to change is if you make some changes to your backend lambdas, which is probably going to be minimal.
Okay, if at all.
if at all. Yeah. Mhm.
Okay.
Now, there's another part to this jigsaw, though. If I go back to here, so we have some sense now, anyway, of how to achieve this. Okay. What if we actually want to uh, be able to associate a custom domain to our full stack app? Now, what do I mean by that, first of all? Currently, for my simple demo here, um, this is the domain name. I'm using the CloudFront generated domain name to access my React app. So when I enter this URL into a browser and hit return, that's going to send a request to CloudFront. Maybe if I just talk briefly about that. Time, running out of time. Uh, let's use this. Okay. Let's supposing now. So we've got S3. Let's supposing we've got a. I'm just going to put API here. Uh, API, this now is representing my API gateways, plural, because I've got an auth API and an app API. But it's look, it's just a serverless API plural that I have up here. And so the way things are going to actually work is my browser is going to send a request for essentially the React app. That request is going to hit the edge location server. It may have it cached, it may not. Let's suppose it hasn't. So it goes to the S3 bucket. That returns the index.html. That's cached here locally, sent back to the browser. Within that index.html, there are references to a JavaScript file and a CSS file. So they are going to be requested uh, those requests are going to go to my edge location server again. It's not going to have them cached. It's going to go back to the bucket and get the bundled JavaScript file, return it back, cache it, give it to the browser. Similarly for the CSS bundle, goes to the um, edge location server. It's not going to have it in the cache, goes back to the bucket, gets the CSS bundle, and gives that back to the browser. So my browser now has the index.html and it has the bundled JavaScript file and the bundled CSS file inside here. What that means is it now has essentially the contents of the dist folder. And it runs the JavaScript code, which is my React code. It runs that inside the browser. Part of that execution involves communicating with my APIs. Um, um, and so that communication is directly from the browser to my API. CloudFront doesn't have any involvement in that. CloudFront is not fronting my API. It's only fronting the React part of my full stack app. So my React app, which is now running inside the browser, is communicating directly with my own APIs, my auth API and my app API, just as it would have been communicating directly with TMDB, which is a third API, not deployed onto AWS platform though. Okay, and that communication that's going on here directly from the browser to, okay, it's going through the network, but going to my custom APIs That is as a result of, the fact that I've got these two use effect hooks. Isn't that the term? I was looking for that term actually. These two use effect hooks in my React code. Yeah. Um, okay. That's just trying my way of explaining how all this actually works at runtime once you've done the deployment. Okay, the last piece though is rather than using this kind of ugly CloudFront generated domain name for my full stack app, it would be nice if I had a custom domain name. And in my case, I have a domain name. I've decided to give a domain name as follows. My app, which isn't great, myapp.dearmid.connor.com. So dearmid.connor.com is a domain that I have bought for myself, and they're very cheap to buy these things. And I've got a subdomain within dearmid.connor.com called myapp. And so if I hit return on this, it gives me my app. And this is arguably a more friendly uh, domain name than the ugly one that was generated by CloudFront. So the question is, how do I associate this custom domain name with my CloudFront distribution? That's essentially what I'm doing. I'm associating a custom domain name with a CloudFront distribution. So it's completely related to the front end. It's got nothing to do with the back end RESTful APIs.
Dearman, I gotta ask, is this a must for the assignment, or
Uh,
is this more about
if you're aiming for the top mark in the grade spectrum.
okay, so you're saying go off, buy a custom domain and implement this.
Yeah, but the custom domains are cheap. Like you're talking about
Mm.
maybe, I don't know, $5, $10 per year. And
Okay,
after you bought it, you can actually relinquish it after the assignment, and you probably only incur about $5 at most, I'd say. You know,
okay,
yeah,
okay.
they're very cheap. Um, but the question is, how do we do it? So. Yeah, the objective is associate a custom domain name with our CloudFront distribution, our CloudFront enable, yeah, CloudFront distribution. Here are the steps. Some of them are manual by a domain name. Last year I came across this kind of oddly named registry called portbun.com. Okay. Now last year I think they were the cheapest, but some of you may actually already have bought a domain name using some other service. The domain name that I bought it with the AWS service itself, but it certainly wouldn't be the cheapest of them. Now, maybe it's $8 rather than $5 or six rather than $5, but if you haven't already bought a domain name and you'd just be interested in following through on this, um, the portbun.com platform sells domain names very cheaply, and it's legitimate. And I'm also giving you a link to a video that just steps you through buying a custom domain name, and you can choose whatever domain name you want to. It has to be .com or .org, I think, for Portbun. I'm not sure. Maybe it has some .ie access as well. So you've bought your domain name at this stage, step one. Step two then is in the AWS Route 53 service. So this is a new service. Some of you that would have done the cloud architecture module in the first semester would have come across Route 53. The Route 53 service is a domain name service provided by AWS. All of the cloud platforms provide a DNS service. It's essentially a place for kind of associating your custom domain name with an event, associating it with a either an API or some sort of backend. Now you've got to, I'm saying here in the AWS Route 53, you've got to create what's called in AWS terms a hosted zone for your domain name that you created. So in my case, if I bring up Route 53, this again is also a manual step.
But this will be a once and done step, Dermot,
Correct.
I'm assuming. Yeah,
Correct.
okay.
Yeah. So we can't do this via the CDK, unfortunately. So it has to be a manual. And if I go to hosted zones here, and now just by way of background, so I have bought a domain called dermotoconnor.com. I bought it off AWS. And so in my case, when I look at domains down here and I look at registered domains, here's proof that I have bought this domain from AWS. But as I said, you can buy your domain from any service provider you wish. Porkbun might be the cheapest one, or you may know of another one. Whatever domain name you've bought, you do have to come back to Route 53 and essentially attach or tell essentially maybe Route 53 about your domain name that you have bought elsewhere. And the way you do that is you create a hosted zone for your domain name. So you go into the hosted zone section, select create hosted zone up here, and all you've got to do is give it in the creation of the hosted zone. I can just go into it, right? You just specify the domain name that you've bought, and that's it. You don't have to do anything else. Just create that. Just create it. You can give a description if you want to, but it's not necessary. So we've done that. There is a default one hosted zone created for everybody that has an AWS account. That's what this second hosted zone is there. So I've done step 2. Back to my slides. Step 3 is copy the hosted zones list of named servers. This again is a manual step. Now, when you create a hosted zone, what AWS will do is it will tell uh, its some of its DNS servers, which are completely separate. It's a separate sort of network of servers, which are all running the DNS service on them. You need to tell some of those other servers about the hosted zone that you have created and the domain name associated with that hosted zone. And so when you create a hosted zone, if I go back to it here, and if I go into my hosted zone that I've created, what AWS does is, if you just expand this, it associates a subset of its DNS servers with your hosted zone. Okay, so you need to copy that list of servers and you need to tell the service that you used to register your domain name. You just need to tell it that list of servers. You need to give it that list of servers. So that depends on really which service you use to buy your domain name, whether it be porkbun.com or GoDaddy.com is another service that you can use to buy a domain name. You just need to tell it, you need to give it this list of DNS servers that are associated with your hosted zone. So it's a simply copy and paste. Now, where you paste them to depends on the service that you bought your domain name from, but I'm pretty sure it's a very straightforward step that you need to do. In fact, if you use pork bun to buy your domain name, if you watch this video, I'm pretty sure in the video it tells you how to copy the name servers or where to put the name servers, your AWS name servers, where to copy them to. In my case, um, because I bought the domain name from AWS itself, then in my case, I went to here and here, and you can see, look, here are my name servers. So I think I had to do a, edit name servers. So there'll be something equivalent to that available to you in the service that you used to buy your domain name. But what you will be copying in, though, are the name servers that were uh, used by the AWS servers, AWS service, the Route 53 service when you created your hosted zone. Bit of a mouthful now, but anyway. So step 3 is also manual. So step 2 is manual. Step 1, 2, and 3 are all manual, but they sound a little bit more complicated than um, uh, they sound more complicated, or I've made them sound more complicated than they actually are, I think maybe. Okay, let's move on to step 4. Okay, so we've bought our domain name. We've created a hosted zone on the AWS Route 53 service. And when we created the hosted zone, AWS Route 53 selected a subset of its network of DNS servers. It selected a subset of those to record our domain name and our hosted zone. You copied that subset of servers, DNS servers, you made a copy of them and told your domain name registry about those servers. So you've done that. The next thing we've got to do is we've got to create a HTTPS certificate for our domain name, because presumably we want to have everything running over HTTPS as opposed to HTTP. So we need to create a certificate for our domain name, and we do that in the AWS world. Now, AWS has a service for creating HTTPS certificates, and it's called the ACM service, the Amazon Certificate Management Service. This service, though, is only available in one of its US regions. It's not available in the EU West 1 region or any other region other than US East 1. So, but we can automate the creation of the certificate in the CDK using the CDK framework. So we need to see how to do that. How do we get how do we code a CDK to create this certificate for us? And finally, then we need to attach that certificate with our CloudFront distribution. What's step 6? Add a record to your hosted zone to redirect requests to your apps CloudFront URL. Okay. So in terms of step 4, we go back to our CDK project. So step 4 is simply just to create a certificate for our custom domain name so that we can use HTTPS rather than HTTP. And you can see there in my browser, it's HTTPS that I'm using, which is obviously better from sorry, that's not I should be showing you this. Yeah, I'm using HTTPS for security reasons. So that means I need a certificate for this domain name, and I can automate that. Let's go back to my CDK project. And that's what this stack is about. What does this stack do? It, let's see. It first of all just grabs a reference to my hosted zone. That's all it's doing here. I'm just getting a reference to the hosted zone, and I'm using the hosted zone's ID and my uh, and the actual domain name that that hosted zone is associated with. Now, for convenience or otherwise, I do have a sort of an environment file of a sort in this CDK project. If you look at, where have I got it? Oh yeah, here. I've just got it's a TypeScript file really. It's not a .env file. It's a TypeScript file with some environment variables. I didn't have to do it this way. I could have hard coded them, but inside in this environment file, you can see I've got a variable that will contain my default region, which in my case is US1, my account number, that's your AWS account number, the ID of your hosted zone that you've created. Now, where did I get that? Well, if I go back to here, that there, that's the ID of your hosted zone. So you just got to copy that and paste it in there. And finally, I've also declared a variable called domain, which contains your domain name. So they're inside an environment file of a sort, right? And so in my stack file, I reference them in this stack file here. So I grab a reference to my hosted zone, and I use the ACM service to generate a certificate for uh, for a particular subdomain. I've just decided to use a subdomain for my React app. My subdomain was myapp.diarmaidoconnor.com. And I've just kind of put it up here, right? I've decided that's going to be the subdomain for this React app. So I'm getting the ACM service to generate a certificate for this domain. And okay, this is just boilerplate. This is how I want the certificate to be validated whenever it's used within any communication. This line here is, you can treat it as boilerplate. That's all that's in the stack, is it? Oh yeah, all I'm doing, I do want to, however, I want to share the certificate that is generated. I want to share that certificate and use it in the other stack. The other stack is the stack that we've been looking at up to now, this stack here. This is this stack that contains, all of my CloudFront and S3 and my backend APIs, etc., etc. But I want to use the certificate that is generated inside in this stack. I want to use it. In fact, I want to use it in the CloudFront distribution as part of the CloudFront distribution configuration, which is contained within this stack. So that's why uh, in this stack, I need to have some public read-only uh, instance variables for this stack class. And you can see I've got two of them. I actually want to share the hosted zone reference and the certificate reference. If I now jump up to here, So here's the bin file, and you will remember in the bin file is where you instantiate your stacks and you instantiate your CDK app. Here I'm instantiating my CDK app, nothing new there. I'm importing some environment variables from that environment file that I showed you. I'm importing the my default region and my account number. Here is where I'm creating an instance of my what I'm going to call my my certificate stack, the one that I've just been looking at there a few moments ago. And I'm attaching that stack to my CDK app. And here is where I'm creating the second stack. This second stack is the one that contains all the CloudFront S3 API gateways, RESTful APIs, contains all of that stuff. So I'm creating two stacks because it is a multi-stack app. And um, the only reason it's a multi-stack app is because the creation of the stack that creates the certificate that has to run in the in the US East 1 region. You can see here I'm passing in US East 1 as the region for what I kind of call loosely refer to as the certificate stack, the stack that creates the ACM certificate. Whereas here, the other stack is running inside my default region. Region here is being read from the configuration, the environment configuration file that I showed you a few moments ago. This file here. So let's see, where are we? I know we're way over time, but I hardly guess this would happen. When you've got stacks that are deployed to different regions and you want to share some kind of information between those stacks. In this case, like what we want to do is we want the stack that creates a certificate. We want to share the certificate reference and pass it into the full stack. Like you can see here, I am passing into this stack here, the one that's creating all the CloudFront stuff. I'm passing in the certificate. Where is it? Here. I'm passing in the certificate that was created by the first stack, and I'm also passing in the hosted zone reference that was created in the certificate stack. Also, because the two stacks are running in different regions, there is another setting that you have to enable, which is this setting here, this cross-region, what's it called? Cross-region references. You have to enable that as well, which if these two stacks were in the same region, you wouldn't have to bother with this extra configuration setting, but because they're in different regions, you do. Some of you may not have played with multi-stack apps in the first assignment, and just to mention something briefly about that, which is if we look at, let's say, this stack here, because I want this stack to share some information with the other stack, the way you do that is you declare instance variables which are annotated with public read only, and they can be anything really, but in my case there's one for referencing the certificate and one for referencing the hosted zone. You make them as public read-only instance variables of the stack that instantiates them. And by making them public read-only, that means now you can reference them within your bin file, and that's what I'm doing up here. If I go back to here, I have references to cert stack dot certificate. Cert stack is just this here, and I'm referencing one of the read-only variables here and here. Now, I'm passing these as custom properties into this second stack. So how do I tell the CDK framework that these are two legitimate properties to pass into this stack? And the way you do that is, if I look at the code for that second stack, this one here, if we, let's see, here's, we know a stack is a class. Okay, so here we're declaring our full stack double stack, unfortunately. The constructor for any stack has three arguments. There's the scope argument, which we know about from before. There's the ID argument. And the final one, which we haven't looked at up to now, the final argument of a stack constructor is called the props stack. Now, by default, there is a default type for this props argument, and its default type is stack props. But we want to extend that default type, and that's what we're doing here. We're defining a new interface, TypeScript interface. Well, I'm actually using type aliasing, but I could have used a type interface, which is comprised of stack props, which is defined within the CDK framework, and I'm adding two properties essentially to it, one called certificate and one called zone. And I'm calling this new type full stack props, and I'm making that the type for the props argument of my constructor. And that's what allows me, if I don't have this code here, then I am going to get a TypeScript error when I try to do this, because it doesn't recognize certificate and zone as being valid keys within the stack props type that comes with the CDK framework. Now, if I go back, fortunately, we're not finished. So if I now go back to this stack, the one that contains my CloudFront distribution, I am passing into it now my ACM certificate, and I'm passing in the hosted zone. And where am I using them? Well, if we look down through, we actually have to go into this custom construct, because I'm passing them in. You can see that I'm actually passing them on into here. I'm passing the certificate and the hosted zone reference, passing them down into this custom construct of mine. So let's follow through on that. And if we look at the CloudFront distribution, that's where I'm using the certificate. So that's what allows me to associate the certificate with the CloudFront distribution. And in the domain names, as well as the domain name that is auto-generated by CloudFront for this distribution, I'm also associating another domain name called site domain. Where is site domain defined? That's defined here at the top of my file, I hope. Yeah, there, site domain is comprised of my app plus domain, and domain is just imported from that environment file. So this will be assigned the value dermot.o'connell.com. So myapp.dermot.o'connell.com is the full string for site domain, and I'm now attaching or associating that alternative uh, domain name with my distribution as a result of this line here. So I'm linking the certificate and the custom domain name with my distribution. The final piece of the jigsaw is this piece here, where I have to add some more entries to Route 53. And the purpose of the code that I've highlighted there is essentially, let's just say it's tying it all together rather than going into, because we just don't have time now, right? But you can literally cut and paste this and you don't have to make any changes to it. Look, you can see that I'm adding a new entry to, I want to add an additional entry to my hosted zone. The entry relates, the type of entry is an what's called an A record, which I don't have time to go into now. I'm targeting my site domain, myapp.dermot.o'connell.com. Let me just put it like this, right? The result of having that CDK code means that if I go over to, when I do the deployment of this stack, then if I go into Route 53 and hosted zone, it actually adds some additional entries down here. In particular, it added, I think, this entry here, and probably all three of them actually were added as a result of deploying that stack. When I created the hosted zone, there may have just been one record in this list of records, but when I deployed my CDK app, some additional records were added as a result of this entry here in my CDK code. I'm not going to go into any more detail other than that. So that's the final part really, to get the custom domain working. Right. Did I leave anything out? Yeah, that was really step 6 there in the sequence. So my final bit of advice would be, I suppose maybe rewatch this lecture, and also I will give you a link to the GitHub repo that contains all of the code in this CDK project. And what I've just done is there will be a folder called reference only, and inside in the reference folder is where I put the source code for the React project that I've used throughout this lecture, so that you just have it. So if you want to play with this CDK project a little bit before you start using it for your project, what you might do is when you clone the repo, just take the contents of the reference only folder, make a copy of that somewhere else, and you can run your npm run build on that, and then copy the dist folder over into this project. You can see the dist folder up here. but as its name suggests, the reference only folder is there for reference purposes only. It won't be included in when you do a CDK deploy of this CDK project, it won't be included in the deployment. Okay, as I anticipated at the beginning, just an awful lot to get through, but maybe if I just finally go back to the assignment specification, which, let's be honest, that's what you're really interested in. And if I go into here, if we go down through the grading spectrums for the good spectrum, you don't have to use CloudFront at all. You just use S3 as a website host, but you have to then manually or hard code the URLs of your API, your Auth API and your App API into your React app. For the very good spectrum, you use CloudFront, but you don't use any of the custom domain stuff. I think that's what we're getting at there. Let me just see again. Assignment 1, front end. Yeah, you're just using CloudFront, and you're manually putting in the URLs of your backend, and maybe you've got a simple sign-in form. You can do the registering of users, do that using Postman as we did before, and I did that as well. You can see I have Postman here running, so I use Postman to register a user and to confirm their registration. And so your React app, all it will need to demonstrate is user sign-in. So you might have a simple sign-in page in your React app. When the user clicks submit, they've entered the username and password, click submit. Your React code should then send that username and password to your Auth API, and it should return a token, JWT token. You can store that token somewhere within your React code. And all of this now should probably happen in an app context. That's a React app context. And you can use that token then maybe to allow user, let's say, to view all of the reviews in your DynamoDB table. Remember in assignment 1, you were able to post reviews into a DynamoDB table. Well, requesting that from the React side, let's supposing you need to be authenticated before you can request those reviews. Or even better still, you actually have a simple web form which allows the user to add a new review to the reviews in your DynamoDB table. And in order to use that feature within your React app, you have to be authenticated, because the post endpoint in your backend API will check to see, does the request include a token? But there's no custom domain stuff going on here at all. And in the excellent, let's say full stack deployment, automated. By automated, I mean you're now actually picking up the domain names of your Auth API and your App API using that config.json. Okay. That's what's going on here. Whereas in the previous grading spectrum, you're hard coding the domain names, the URLs of your Auth API and App API. Here, you're automating it. And in the outstanding spectrum is where you bring in the custom domains part to it. Okay, I don't know if there's anybody still there or not, but again, I'll pause again for a second, for a few moments.
Still here.
Yeah, if there are any questions. No. Okay, thanks for hanging on, those of you that are still there. And Frank will be um, monitoring the lab on Thursday, so I probably won't get to speak to you again before then. Okay, thanks a lot. Bye for now.
Thanks, Dermot. Good luck.